Okay, so today we will talk about the basic knowledge of the protein. So we want to talk about is the protein related to amino acids. Dr. Kenny have a question for you. What is protein? So I think you know it is very important. So protein originally coming from a Greek word called protist. That means first kind, or some textbook will say very first kind, which means it is important. Now we learned in different classes, obviously it is very important for our biology body. So the biological function we will briefly mention here. That is encoding. It's a support function. Let's say you have a muscle, you have a collagen, you have a joint, okay, even the bones, there's a lot of protein that support. It is a sensor. It is a sensor for any of the stress environments, especially for bacteria. They are, especially the integrated protein in the double layer of the cell membrane system. It is a contribution for the hormone to formalize. And it is important for the protection. So let's say we talk about antigen reaction. An antibody is a protein. It is obviously important for biochemical reaction. We'll let them have more efficient. That is called enzyme. Enzyme basically is a protein. And the last one, obviously, this is a nutrient. So gave you a lot of the nutrients. So these we just very briefly mentioned because we basically want to talk about is the chemistry. Okay, the third thing we want to mention is what are the major type of the protein we have in our everyday life. Then they have a different category. The first category we call it simple protein. So simple protein could give you some of the example. Let's say we had albumin. This is usually in the egg products. So egg white, you have it. And we also find the albumin only dissolve in water without salt. And the second category, we call it globulin. Globulin. And we find this globulin, a good example, let's say lactoglobulin, which is a protein actually has antimicrobial activity in milk. And this can be dissolved in, we call it a neutral salt solution. And then we have another one called globulin, or we call it this category we should call it glutenin. Globulin and glutenin. A good example is Dr. Kenny mentioned myosin acting in muscle food. This is the muscle food. And we also very popular in China, in Asian countries, is glycine. And beta-conglycine. beta-carotene in soybean. And there is another example, which is called histone. For example, you have arginine, you have arginine and lysine, we call it a histone. Okay, so arginine, lysine, this is a category called histone. So this is a simple protein, the first category. And the second category, we call it conjugated protein. The conjugated protein, which means there is two different type of the macromolecule they combine. There could be like lipoprotein. It could be nuclear protein. It could be phosphoprotein. It could be glycoprotein. And it also could be, we call it a chromoprotein. This is what we talk about like hemoglobin. It's a chromoprotein. And the last major section is derived protein. So derived protein, which means you using chemical or biological methods to isolate it. Now, a very good example, since I'm a microbiologist, there's a very good example, is peptide. And also tryptophan. Both of these using for a neutralized solution for bacteria. We have a buffered peptide water, remember? BPW equals a buffered peptide water using for the dilution of the bacteria, especially the 0.1%. That is actually a protein, which is derived protein. On and on, there's a lot of category, but major category is right here, okay? So that's one of the category we have. Now, protein also has a very important characteristic called denaturing. So denaturing, that means you use acid, alkaline solution, or using heat, okay, will be break down. I will say that it's a high level structure. Break down high level structure, but not the amino acids sequence. Now, it sounds very, it's a horrible thing for denaturing protein. However, in a food processing, denaturing not means it's really bad. So very easy example. If we cook an egg, okay, the egg albumin will be solidified, then become a foam in an egg products. That's really good. And if we cooking a steaks, we using heat and the actin myosin cross bridge of the muscle. Cross bridge of muscle will break down. That means it will be more tender. Okay, tenderization. That's a good thing. Make the beef is more tender. Another thing is that you may know, I don't eat that, which is called egg mayonnaise. Sometimes we add lemon juice or some of the other acids, and we're causing like egg mayonnaise mayonnaise dropping. And that's also a good thing. Droppings. So, does not mean it's always bad. In the food processing, we need those denaturing. Even Dr. Kenny mentioned about the hot dog processing. We need those denaturing to make sure the protein is engaged, or we say emulsified with fatty acids and other products. So denaturing in the food processing is not really the bad thing. Okay, so these are some important items we want to mention. Another thing we want to talk about is that we don't talk genetics here, but very important. We want to go over briefly how we get the protein. Let's say from a DNA sequence. And this is go back to our central dogma. So we all know that. You learn in different classes. So we had a DNA. Okay, a DNA sequence will be 2 double bonds, and 5 prime to 3 prime, and then 3 prime to 5 prime. And we have those genes. Let's say we had a ATGC, then we have TACG. This is a double bands of the DNA. The DNA, first of all, they will do is we call it a replication. And then we're going to a very important stage. We're going to RNA, and at this moment we will say it is mRNA. So we do like that. The mRNA will be formed. That is called message RNA basically. This is called transcription. Transcription. And we know there's 2 bands. So the top one is a coding band, the bottom one is a template band. And because the mRNA sequence is very similar to the first one, the only difference is instead of you have T, you replace with U. So that will be like this. Okay. Now when you have an mRNA, they also will be to form a tRNA. Okay, there's a tRNA, let me use another color. There is a tRNA will be formed. Okay, the tRNA will be formed. And then later on, this something will be happens is in a very special structure, what we call a ribosome. We call it in ribosome, and we have 50S subunits, 30S subunits. Then we have a 16S rRNA there to recognize the sequence. And then later on, we'll have generate an amino acid sequence. Now, of course, there's a lots of others. The folding will happen, then finally become a polypeptide, then become a protein. So later on, it will become a protein. And this is a process we call it a translation. Now, if we really want to talk about the chemicals, then we only need to draw one thing that you will understand is how they connected with tRNA. So I had this is a ribose, 5 carbon ribose. This 1 carbon area is always attached to a base, like we drawn it before. And the base will be AUCG, adenine, uracil, cytosine, and guanine. And this will be HOH2 prime, and 3 prime, this is important. And this is a 4 prime, this is 5 prime, is important because we go here, we will connect it to our phosphates. That's always important. And then the phosphates will be connected to something I'm going to draw right here, will be connected to a very special stuff, will be a tRNA. So like this, variable arm, T-theta-C arm, anticodon arm, they go here, and they go here. So this is 5 prime, and this is 3 prime. Okay, and here the tRNA, we call it a clove leaf shape, and they are carrying on the anticodon, which is right here. Okay, so this is called anticodon arm. Now, where are they going to connect it with the amino acids? That's always at 3 prime. So 3 prime became here. You'll be connected with double here. You connected with O, and you connected with R, and you connected with NH2. Okay, so that's what the procedure looks like. Wait a second. OCH. Wait a second. This is wrong here. This needs to be OCH. Wait a second here. This is O. This is wrong. C. O here. CH. That's R1. That's NH2. Okay. Very, very long. That's connected. That's what happened there, and for the 3 prime bonds, 3 prime carbon. So this is the process, and we also know the first one is always MET, which means it's methionine, and we'll mention about that real quick. So the R side chain is this. That's methionine. COOH, that's H. O is a methionine. And we also know the genetics they're using a 3-letter system, we call it a codon. And we have a position number 1, number 2, and number 3. They are more strict for the position number 1 and number 2. And the position number 3, they give some flexible, and we call it wobbling status. Okay, and how many genetic codon we have? We had 4 here, 4 here, and 4 here possibly. So we multiply together equals 64. However, we have a 3 stop codon. So we actually only have 61 genetic information, and these 61 genetic information responsible translation 20 amino acids. Okay, so this is, we go very briefly about the genetics behind the amino acids, how they formed, and which means the central dogma. So it's not a genetics class, so we're not going to talk these too much. We learned in your other class, even in my microbiology class. So next one, we want to talk in detail about the amino acids. So we want to go number 6. We will talk about amino acids. Okay, amino acids, we'll just use the acronym is AAS. That means amino acids. So there is a basic structure. The basic structure is NH2 connected to C. C is in the center. Have one is H. The proton is always the same. So you have COOH, and then you have R side chain. And we call this NH2 is amino group. This proton is always the same. COH is carboxy group. And in the center, this C, it is very important. We call it is chiral C. And because it's like a mirror, it will have 2 different types of the isomerized amino acids, which is L and D amino acids. And we know that in our real life, there is widely existing is L amino acids, And the amino acids not existing too much. Most of the time we make them in the lab. And it is not really flat, although most of the textbook writing as a flat, there is an angle here. This is called a PSI angle. And this is, we call it a theta angle sometimes. So there's the angle there, okay? This is the chiral C. So most of the amino acids, the basic structure looks like that. Now we also will be mentioned later on, some textbook, this goes to NH3 plus, and this goes to COO negative. That is called the Wheeler status or dipolar status. We will mention real quick. Okay, so amino acids, the basic structure are the same. And we already mentioned there is a 20 amino acids widely existing in our real life. And their difference is this R-side chain. So we're going to go over all these R-side chain. Most of the time I can remember all of them, but I have a very busy in the morning, so I'll see whether I still can remember. These amino acids, if you want to remember them, it's not very difficult. There is an order can do. Basically, the order can do is we categorize them into different categories, which is first of all is non-polar, no charge, so no charge, and they do not dissolve into water, so we call it hydrophobic. They usually not dissolve into water. Okay, so let's talk about these one by one. The first one is H. That's very simple. Glycine. The second one, CH3. Alanine. This not much to talk. The next one, CH, CH3, and CH3. Valine. This we have to mark it red because this is the essential amino acids. Valine. Okay, the next one because CH3. Let's do that. CH2 first. CH2, CH, then we go CH3, CH3. This is leucine. Okay, leucine is also essential amino acids. These are the easy ones. Okay, you know H, CH3. So you have a CH, of course, you CH3, CH3, because otherwise it's unbalanced. So you have a CH2, CH3, CH3, CH3. That looks like good. Since you have a leucine, there is a isomerization status comes out, which is we draw CH3, CH2, then we draw CH, and then go CH3. That is called isoleucine. Basically, it's the same as leucine, but the structure is different, so we call it isomerization. This is also essential amino acids. So next one is circle. So we have to draw the whole thing. So we have to draw NH2, CH, COOH, then will be CH2, 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 then go here. This is called valine, leucine, and this is called proline. Proline. Okay, this is the easy one. Then we move on to a relatively difficult one because we have a phenyl group there. So the first one is phenyl group add CH2. This is phenylalanine. We add a phenyl group. Alanine, add a phenyl group. Okay. Sometimes we just draw a circle there. So phenylalanine. Next one, a little bit difficult. Phenylalanine is also an essential amino acid. So we just phenylalanine, essential amino acids. Next one is a little bit difficult, so I use a different color. We need to have this guy right here, 6 carbon, 5 carbon. There you go, NH. And you have CH2 right here. This easy. Don't forget double bonds right here. What is this? Tryptophan. Tryptophan. And then next one, little bit arguments. We will talk about the first one, which is this is also essential amino. We'll have sulfide. So what's that? CH2, SH. Cysteine. I look at the textbook. There is about 70% listed this one is charged. There's a 30% listed this one is non-charged. So I teach microbiology. In our microbiology book, we listed this one as non-charged. So I just put it there, cysteine. Next one is, we just mentioned, methionine. So CH3, S, CH2, and CH2. That is methionine. Methionine. And always remember, that's important. That is the first one for the translation. So this is obviously is amino acids. Okay, so is essential amino acids. So goes here. We have the first category is no charge, hydrophilic and non-polar. The second category, which is, we call it a polar, no charge, hydrophilic, which means it started to dissolve in the water. So the first one is CH2OH. It is serine. Then we have CHOH, CH3, serine. I don't know why, but this one is essential amino acids. Okay? Now, next couple. CH2, CNH2, this is asparagine. And then the next one is CH2, CH2, CONH2, this is glutamine. And do not forget, there is another phenyl group of the amino acids comes out, which is phenyl group, CH2, OH, which is tyrosine. Okay, so we down here, which is polar no charge, then we go a very important group, is polar charged and hydrophilic. So the last group will be polar charged and hydrophilic. Okay, do you mind moving a little bit? So this one I always say, make sure it's, this one I always say, you have asparagine here and glutamine here. So it's easy to remind you. This goes up to here. This goes up to here. We'll have two things happen, which is CH2, CO, and O negative. You have asparagine. This is aspartic acid. Now acid, it is negatively charged. You have a glutamine. So you have a glutamic acids. CH2, CH2. This is glutamic acid. This is also negatively charged. Since we talk about negatively charged, then we need to talk about the last one. Last three is positively charged. These three positively charged is very interesting. The first one is always difficult to do because that's a little bit different. Like that. So you have NH plus NH right here and CH2. This is called histidine. The next one is relatively easy because it's a very long CH2. So that is CH2 go up, CH2 go up, CH2 go up, CH2 go up. Then you have NH2 plus. This is lysine. Okay, remaining last one is arginine. Arginine and the lysine, a little bit similar if you do not be careful. CH2, CH2, CH2. Then goes here is NH. Then you go C, double bonds, NH2 plus. Then you go NH2. This is arginine. So that's done for the 20 amino acids side chain. So we want to talk a little bit about some of that. First of all, something we haven't finished about the essential amino acid. What do you think what the others are essential amino acids? I think lysine obviously is, histidine is obviously is. So how many we have? Valine, leucine, isoleucine, 3. Phenylalanine, that's 4. Tryptophan 5. Methionine 6. Serine 7. Histidine 8. And the lysine is 9. So 9 essential amino acids. Some textbooks say 8. Okay, it doesn't matter. I mean, they variable a little bit, but that's 9 essential amino acids. We have phenylalanine, tryptophan, tyrosine. Those 3 we have a phenyl group, so we call it a phenyl amino acids. That I don't want to emphasize too much. Now something here I do want to just review a little bit, because we are microbiologists, we always want to go back to talk about phenylalanine. Do you remember in my class we use this in a lab section? Phenylalanine, if you draw the whole thing, it is like this. So we always go back to draw the whole thing. Then we have this on the top. Okay? That's phenylalanine. We said in the lab we test a special bacteria, Proteus vulgaris, has deaminase. So if the bacteria has deaminase, what will happen? Obviously, is this guy is gone. So amino group is gone. What the left? The left is on the right side. Is this circle. What is that one? Phenylpyruvate. Modified pyruvic acid is modified pyruvate, so bacteria could use this one instead of pyruvate going through citric acid cycle. So that's phenylalanine. Second one I want to mention, tryptophan. Do you remember? Except Ian and Jessica, not many of you taking the class yet. So tryptophan, if you cut down from here, what is this section called? This is Indo. And Indo is a major component for the Indo test. Indo test is a very special and easy test for what? For E. coli. E. coli is Indo positive, and we have a very special reagent called COVAC. Why I want to mention this? Because Dr. J did a project with one of his master students and using an Indo test to do a rapid testing for E. coli. So that's why I want to mention about the Indo, okay? Masani already talked here. Asparagine, we will mention later on. Asparagine, widely existing on chips. Not really in chips, in tomatoes. So tomatoes, you cut, you slice it, then you cook it using oil, will become chips or French fries. Then going through Maillard reaction, this asparagine will generate a carcinogenic material. We call it a minimal carcinogenic material, acrylamide. Now we will mention this. Glutamine, what you like is glutamine salt. So we say sodium glutamine. Sodium glutamine will be a very delicious component if you add a chicken soup. However, that's not good for health. You don't eat that too much. So that's glutamine. Aspartic acids, glutamic acids, not many. This is a joke we talk about. If you don't remember, histidine, lysine, and arginine, his or her legs are basic. This is a joke which is said that the 1980s or 1990s graduate students, undergraduates walking around the campus and just to show off they have long boots and show off a little bit of fashion, not really care about the study. So that's a joke, okay? Why we have this joke? Because you can remember H is histidine, L is lysine, A is arginine, and they are basic amino acids. So we have a sentence called his or her leggers are basic. So that's a story for the amino acids. So we finished here. Then we want to go next one. We go back to Dr. Kenny's question about the amino acid is some of the characteristics. And in Dr. Animan's textbook, they say it's called acid-base property of amino acids. So we go question number 7 is acid-base characteristics of amino acids. So what is that? This is the one we need to go back to talk at the beginning. At the beginning right here. Okay. NH2, CH. We just mentioned the all side chain difference and COO. Some of the textbook, they will write NH3 plus and write like this. What this means, this tells you at pH around the neutral 6 or 7. This is we call it alpha. Alpha amino acids, amino group, and alpha carboxy group. Or ionized, which means they are charged. Okay, charged. Could be positive or negative. At this moment, we call dipolar status or Zwitter status. So therefore, there is 2 different directions could go. You could go that direction, you could go this direction. Go the left direction, we call it protonation or protonate. Because we're gonna add a proton, go to carboxy. So what it looks like? This will looks like NH3 go CRH and COOH. Okay, that is actually, we call it is positively charged. And we also could go right side, we call it a deprotonation. Deprotonation is this guy, the proton is gone. So this will happen is NH2, CRH becomes COO negative. So this is a negatively charged. And we call this is pKa value, and this is we call it a pKa2 value. Therefore, it comes with a second concept. The pH at which the pH at which the ionized carboxy ions equals associated carboxy ions. This is called pKa1. And the pH at which the ionized amino group equals non-ionized amino group. This is called pKa2. And then it comes out with another question. Dr. Kenny asked you guys last time. Add a pH at which Z dipolar ionized ions are uncharged, or we say electrically neutral. What is this called? This is called isoelectric point. And this is called IP. Is that right? PI, or we sometimes, we call it PI. Now, Dr. Matak and Dr. J did a lots of research back in last 20 years. Find a different formula, see the actual electronic point. What happened? We see a very simple example. Water holding capacity at this level, sorry, this is WHC, this is pH. Muscle food around 5.0, the water holding capacity is lower. This is called PI value. Because you're not holding on to water, so what do? If you centrifuge, you precipitate it. And the supernatant is usable. Okay? Now, what's the industry they do? All the meat products we did in the lab, lots of, we add salt, sodium chloride, and sodium tripolyphosphate. We shifted the pH value. So, still at 5.0, it's actually right here. So the water activity, water holding capacity is increased, so they do not lose much water of the muscle, especially during the cooking. That is related to the juiciness tenderness, well, you have a salt there, slightly for flavor. Okay? Now, with this one, there is actually a table. If you guys, a figure, if you guys remember in your biochemistry class, what's the figure looks like? Y-axis, or x-axis, pH value. It starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to 13. Okay, this split into 2. So down here we call it equivalent of HCl, hypochloric acids. And on the top we call it the equivalent of NaOH, sodium hydroxide. Okay, and this goes here is 0.2, 0.4, 0.6, 0.8, go here 1.0, then go top, so that's 0.2, 0.4, 0.6, 0.8, go up to 1.0. What's the curve looks like? The curve will be looks like a little bit like this, then go here, then go top. So we talk about here is pKa1, here is pKa2. How about the flat one? This is electronic point, or isoelectronic point. Okay. Pi is right in the middle. So this comes with next question. How we determine Pi? Not that easy. It really depends on the amino acids. That's why we have to know these all side chain. If it's no polar, no charge, what we do? Very simple. pKa add pK2 divided by 2 is the Pi value. Okay, this is no charge. Okay, if you have something which is acid,